Hello everyone, welcome to AI Plus Club Unilag Virtual Bootcamp, getting started with machine learning. I am Amina Malidia Rufai. I am an ambassador as well as a co-organizer for Open Data Science Conference, Lagos, Nigeria. So today I'll be taking you through Python, introduction to Python for data science. So we'll be looking at basic Python data types, basic Python data structures, functions, as well as models in Python. So you look at the basic Python data types we have. We have strings, we have integers, we have floats, we have booleans. We also have complex numbers, but we'll just take a look at these first three, the strings, the integers, and the floats, because these are really what you deal with the most in data science. So a look at strings and string operations. So how do we define string in Python? So we use a quote, either the single or the double quote. So over here, I'm printing out a string. This is a string. So Python recognizes this as a string. So ideally, programming languages such as Python do not understand text because strings are text, they are not numbers. Okay. So in order for Python to recognize it as a text, we have to enclose it in a quote, either a single or a double quote. So that's just basically what's going on here. So even if over here, I'm using a double quote. I'm using a double quote. So if I run this, I have, see, Python also recognizes it. So what if I have a possessive pronoun, like it's mine, or his bag, something like a possessive pronoun. So how do we do that? We could use a double quote at the beginning of the sentence and then a single quote where we have uh, the possessive pronoun such that Python can recognize. So I'll explain in a while why we have to do that. So see, it's been recognized. So the reason why we have to do that is because if we don't, Python is going to prompt an error. Right, Python is going to, over here, notice that I'm only using a single quote. So this is going to give me an error. Okay, notice that the color of the text also changed. This is going to give me an error because Python is going to assume that this is where the string ends. This is the end of the string. So it's going to bring an error because it doesn't understand what these others are saying. Okay, so if I run this, I'm going to get an error, invalid syntax. Or if I were to have to come over here and put a double quote and does enclose the entire sentence in a double quote and leave this as a single quote. You see, I now have my text in color and I'm no more going to get an error. So that's how you define strings in Python. So we could also define a string using a variable assignment. So variables are just simple containers in Python. They are temporary containers in Python. What do I mean by that? Say I have a bottle where I store water. Okay, so my temporary content for that bottle is water. What if I changed it? Let's say I finished the water, I poured it out, and I filled it with another content, let's say juice or Coke. So the new content for that container is now juice or Coke, no more water, because I've changed what that content is. That's how Python works too. So over here, if I come here and define these two variables, I'm defining a string. Remember I said we define strings using single or double quotes in Python. So I define two strings over here, A and B. Okay, so if I come over here and print A, I'll get what A is. But if I redefine A, because I said it's a temporary container, if I redefine A, or let's say B, if I redefine B as 3, and I try to print my B, I'm going to get B as 3, no more 2. But if I come over here and rerun this cell, it's going to reassume the value for 2. So if I reprint B, notice that it changes to 2. So that's how variables work in Python. So just a quick note. This, though it's a number, it's a string. Why? I've enclosed it in a quote. Okay, we'll see how that works as well. So a quick look at how we can define variables in Python. Okay, so I mentioned a variable is a temporary container. So there are some conventions in Python for naming variables. I encourage you to look at that. For example, you can use keywords such as print to name a variable in Python. The keyword is a keyword. So how you know keywords in Python? If you're using a Jupyter notebook, like what I'm doing right now, the text is going to come out in color. So you know it's a keyword, just like this. So you can name a variable with numbers, starting it. You can name a variable with special characters. The only special character that is permitted in Python to name a variable with is the underscore. So I could have a long variable name and I want to make it readable. I want to improve the readability of that variable. I could just say my underscore name and Python will recognize that. So take a look at how some variable naming convention in Python. So some of the string operations we are going to look at is the length. So length is short for length. So what it does is that it prints out the length of that string. So if I do my len a, I'm going to get 29. Okay, so I'm sure you are wondering why it's 29. Let's see if we could. Okay, so if we count this, I have 2 over here. I have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So I have 26 letters, but why is Python giving me 29? It's simply because Python recognizes space. So these 3 spaces over here, spacing between my and data science, spacing in between data science and Johnny, spacing between Johnny and begins, Python recognizes that. So if I had come over here and try to remove the spaces, you notice I'll get 26. Okay, so you get to understand more that how Python recognizes space when we get into functions. So if I do this again, try to print my len for a, you notice I get 26. That is because I've removed the 3 spaces in between and I'm now getting 26. So that's how the len function works. Again, 29, because I've included the 3 spaces again. So you could also try to look for the type of it, a data by using the type function. Okay, so if I do for type A, I'm going to get a string. Remember when I said, though this is a number, it's going to be recognized as a string because I've included a quote there. So let's find that out. Notice if I try to do type B, I'm going to get a string. Why? Because though it's a number, I enclosed it in a code. So Python recognizes it as a string, no more a number. So I could also try to change characters in my strings to lowercase by using the dot lower function. There, just as you see, I could also try to change everything to uppercase using the dot upper function. And while the dot capitalized changes only the first letter of my, only just M. So it's going to change only M. So if I run this, you notice that only M has been capitalized. So another operation you can do is try to replace words or letters in your strings. So over here, I'm using the dot replace function and I'm saying replace anywhere you see Y. So I have 2 Y's over here. Replace Y with I. So how it works is replace, or you have to state the old. It takes in 2 arguments, old, comma, new. So that's what I said here, old, comma, new. So I'm saying replace Y with I. So if I run this, you notice A has been changed to wherever I have Y has been changed to I. So rather than my, I have me. And rather than Johnny, I have Johnny. So that's how this works. So you could also try to access letters in your strings using indexing. So Python assigns locations starting from 0. So M is going to take location for 0, location 0, and I is going to take location 1. Okay, so if I wanted to find out where M is, I wanted it to print out, I'm going to say print out and then call out the location for that letter, which is 0. Though M is my first letter, but like I said, Python starts from 0. So if I run this, I'm going to get M. And if I change this to, let's say D should be 0, 1, 2. I'm going to get 2. So 2 for my space, and then 3 for my D. Remember I said Python recognizes space. Okay. So the next data type we're going to look at is integers, floats, which are the basic numeric data types we have and their operations. So one thing I want you to take note of, that Python is case sensitive. So a is equals to 3 in calculator is not the same thing as a is equals to 3 in lowercase. Please take note of that. So over here, I define my a is equals to 3. So if I try to print small a, I'm going to get an error. I'm going to get what I defined a as. So I'm going to get what I defined a as previously. So if I had changed this to, let's say, b in capital letter, and I try to print small b, I'm going to get what b was here initially. Okay, because Python is case sensitive. So if I say print, let's say c, and then I say print small c. Remember that small c was never defined. Small c was never defined, so I'm going to get a name error. Please take note of that. So okay. Okay, so if I try to find out what a is, I'm going to get a is an integer, okay, because there are no quotes. Python automatically recognizes numbers. It's an integer because there is no decimal after it. So what differentiates an integer from a float is that for the float, I have a decimal point after it. So even though 3 is a whole number, just simply because I have a decimal point after it, it will be recognized as a float data type in Python. So let's take a look at that. I have a float, and if I try to look for b, I have a float. So other operations we can take a look at is norm. We can the max function rather, trying to look for the maximum value in a set of value, a range of values. So if I do this, I have 30 as my maximum value. Also try to look for the minimum value, and then we have the round function. So remember that some of all these functions, like the round function, doesn't work for strings. You can't try to round a string because how round works, it takes in two arguments and then tries to round off a float to set a number of places in decimal point. So how it works is it takes in the variable name that you're trying to round off and then the number of places you want to round it off in decimal place. So over here, I'm saying round off this to 4 decimal place. If I want this, I'm going to get it to 4 decimal place. And if I wanted it in 2 decimal place, I'll put 2 in there and then I'll get it in 2 decimal place. So that's how the round function works. One last function for the numeric data type is the absolute function. Absolute simply means ignore a negative sign. So over here, I defined b as -100. So if I call in the absolute function for b, I'm going to get 100 without the negative sign. So that's how the absolute function works. So we have various operators in Python. We have the arithmetic, logical, comparison, and identity operators in Python. These are the arithmetic operators we have. The plus for addition, the minus for subtraction, the single asterisk not x, asterisk sign for multiplication, asterisk on your keyboard, double asterisk for raised to power, forward slash for division, double forward slash for floor division, and percentage for modules. We'll see how that works. So remember I said Python recognizes numbers by default, so we can use it as a calculator. Over here, I'm just doing a simple arithmetic operation for addition. I'm saying 6 plus 4, 10. I could also do that by defining variables. Over here, I define 2 numeric variables, 6 and 8 to m and p. I assigned 6 to m and 8 to p. And then I wanted the sum of m and p printed, and I have my value. So there are 2 arithmetic operators you can use on strings, only those 2, the plus and the star, the plus and the asterisk rather. So the plus works in way of concatenating strings, adding 2 strings together. So over here, I have 2 strings defined with variables h and w, and I'm saying, hey, add h plus w for me, add them together and give it to me as one word. So what I did over here is, remember I said Python recognizes space. I wanted a space in between the word. I don't want the 2 words joined together. So if I print this, I'm going to have hello and word with a space in between. That's simply what this is saying. Okay, so, and then for the multiplication operator, we multiply the strings by a particular numeric value. So I'm saying multiply multiply H 3 times. So if I do this, I'll get hello, hello, hello 3 times. So remember, you can't use subtraction and division for that. So single asterisk for multiplication, double asterisk for raised to the power. So over here, I'm just saying multiply 6 4 times, 6 raised to the power of 4. So if I do that, I have 6 times 10 4. Okay, so forward slash on your keyboard for division. So I'm just simply doing a basic division of 7 divided by 4 here. So the floor division is different from the division in the sense that for the floor division, I'm saying, hey, Python, give me just the integer value. I don't want the decimal point. So Python is going to print out just this one for me. Let's see that. Yes, that's what we have. And then for the modulus, modulus is different from floor division as well as the single division as well. So what it does is it's saying, hey, Python, I don't want the integer, so I want the remainder. I want to know what remains after I've taken 4 away from 7. So you notice that I'm going to get 3. Why? If I take 4 away from 7, what is left? 3, right? So if I do that, because so if I do that, I'm going to get 3. Okay, so that's just what the modulus is. If I take 4 away from 7, what remains? That's just the meaning of modulus division. Okay, so so you can also do some variable or reassignment here. So what I did here was I defined a variable called summy and 10, and then so this minus and equal to, I'm saying whatever summy is just minus 3 for me. Minus 3 for me. Remember that variable are temporary containers. So now it's going to assume the value of whatever has been subtracted from 10 over here. And then here I'm saying whatever is the value of sum over here, divide it by 5. So if I run this, you notice that I'm not getting 10 divided by 3, 10 divided, and 10 minus 3, 10 divided by 5, 10 divided, I'm getting 10 minus 3, which is 7, and then 7 divided by 5. Whatever is left, then that's multiply it by 2. That's just simply what's going on there. So for the comparison operators, we have the greater than, less than, greater or equal to, less or equal to, double equal to, and then apostrophe and equal to, which means not equals to. So take note of the difference between the single equal to and double equal to. Why the single equal to is for assignment operator. The double equal to is a comparison operator. Okay, the double equal to is a comparison operator. So take note of that. Why is comparison? We're trying to compare two values. We want to know if this is equal to this, like a wave balance. We want to know if what is on the left hand side is actually equal to what is on the right hand side. We're not assigning labels, we're not conducting any arithmetic operator. So if we run this, we're going to get a Boolean value, which is false, because 6 is not equal to 4. 6 is not equal to 4, okay? So yeah, false. So, but if I try to do this for 3, I'm going to get a true value, because what is on the right is equal to what is on the left. What if I put a quote here? I'm going to get a false. Why? One of them is a string, and one of them is a numeric value. Okay. So here I'm saying 6 is not equal to 4. So if I run this, I'll get it true. And if I say 6 is less than 4, 6 is less or equal to 4, 9 is greater or equals to 19. So that's how the comparison operators work. You can use them for your conditional statements. So we have logical operators as well, the and, or not. So how the and works is that and returns true if both of the conditions are true. Again, you see more applicability with this when you create conditional statements. And returns false if one of the conditions is not true. It will only return true if both of the conditions are true. Now take note of this statement. The both of them, 6 is correct, 6 is not equal to 4 is correct. So I'm going to get a true. So what if I change this to 4? I'm going to get a false. Why? This is not correct, even though this is correct. So that's how and works. Whereas for the or only checks for the validity of one of the condition and returns true if one of them goes true, even if the other is false. So notice that this is false, but this is true. I'm going to get a true value. Why? This is true. So it's like saying either this or this. So it will return true if one of the statements is correct. So not is opposite, not is just negating what is here. So this is similar to what is here, but rather than getting a true, I'll get a false because it's going to say not negate what should come out from here, negate what should be the output of here, which is true. So ideally I should get a true from here, but because I've added this not logical operator, I'm going to get a false. Let's see that. There we have it. So identity operators, we have the is and the is not as well. So the is not compares two statements, just similar to the double equal to, but they are different. Okay, they are different. They are different in the sense that I can say, so I have two books. Okay, both books are data science books written by different authors. So I can say this is a data science book and this is a data science book. However, I cannot say that this book is equal to this book. But if they were written by the same authors, the same book, the same name, I'll say, okay, this book is equal to this book. So that's the difference between the is and the double equal to. Same thing with the is not and not equal to. So basic data structures in Python. So what are data structures? Data structures are simply collection of one or more different data types. So the difference between data structures and data types is data structures can take in a number of different data types, whereas data type is just one data type, just like what we saw. For the data structures, I can put in different data types in one structure. It's a structure, okay? Like we have a building with different rooms or departments. So we have two different types of data structures in Python, the built-in and the user-defined. And our focus for today will be the built-in data types. So for the built-in data types in Python, we have lists, tuples, dictionaries, and sets. We'll be focusing just on lists, tuples, and dictionaries. So the list is mutable, tuples are immutable, dictionaries are mutable. We'll see that in a while. So mutable meaning can be changed, and immutable meaning cannot be changed. Let's see how that works. So you can create a list in Python using a square bracket. That's how you identify a list in Python, using a square bracket. So over here, I created a list called my list, and I define it using a square bracket. Notice that I have different type of data in it. Okay, I have an integer. I have integer values in it, and I also have string values in it. Okay, so if I print this and try to find out the type for what I created, notice I get a list because I define it. I created it using a square bracket. Okay, so I can also create an empty list and add elements to it later on if I want to. I'm still going to get type as a list. Okay, so you can add elements to a list using three ways. You can use the .append, the .extend, and the .insert. We'll see the difference between the three of them in a while. So for the .append, remember my empty list over here, I want to add an element now, so I'm appending hello world to it. So if I do this, I get hello world here, hello world. I could also add today is Tuesday to it. So how .append works is that it adds to the back of. So you notice that it will add after hello world. So yes, so if I try to print, I'm trying to append a list. This is where we get to see the difference between .append and .extend. Notice how .append adds these two lists together. So this my list is the first list I created over here. Remember I created a list called my list over here. So I'm appending the both lists together. Notice that .append added the entire list as a sub element inside my nothing list. It didn't add them as individual elements. Whereas for the .extend, so over here I created another list called another list, and then I'm trying to extend my previous list. So notice for the .extend, rather than adding them the way .append added them here as sub elements, it added them as individual elements. Okay, it added them as individual elements. So that's kind of like the difference between the append and the extend. So you can access items in a list using indexing, just like what we saw for the strings as well. So if I wanted to know what was the index location 1, which is 0 for Python, I'm going to get 1. So if I wanted to get what is in location 1, which is 2, I'm going to get 2. So if I wanted to see what was at the back of my list, I'll use a negative indexing, -1. I'm saying what is behind, from behind. So if I do this, I'm going to get 5. I could also try to change what, because I remember I said it's mutable, so I can change what is behind, what is in my list by just calling out the index location and allocating a value to it. That's just what I'm doing. So I'm changing 1 to high. If I run this, I'm going to get high rather than 1. I could, okay, so this is how the dot insert function works. So the dot insert takes two arguments. It takes in the index location you want to change and then what you want to change. So this is really the beauty, the difference between insert, append, and extend. So for insert, you can decide to choose where you want to put in your elements, not just have it automatically being added for you. So I can decide, okay, I don't want the element to be added at the back. I want it to be added at a particular index location. So you call out the index location you want to change and then what you want to change. So if I run this, I'm going to get high change to just like change status. So you can add elements at a particular location you want the words added to. So this is really the difference between the three methods. So tuples are immutable. We're going to see the reason why. You can't change a tuple once you create it. So over here, and they can be created using secular brackets or parentheses. So over here, I created a tuple, and if I try to check for the type, notice I got a tuple, and I can also access elements in my tuple using indexing, but I can't change them. Okay, so I access the element in my index location 0, which is this is a tuple, the string this is a tuple, and I got that. But what if I wanted to change it the way I did for the list? Notice I'm going to get an error. Does not support item assignment. Yes, because you can't change it. Even if I try to use another method, I'm still going to get an error because I can't change it. So take note of that. But you can use other functions like length to try to find out the length of your tuple. Okay, so we have dictionaries next. You can create a dictionary using curly braces in Python. Okay, so over here, so dictionaries are created using key and value. So I have my key 1 as 1 and the value for key 1 as Python, my key 2 as 2 and the value for key 2 as data science, etc. So if I try to get it, I'm going to get a dic, which is a dictionary. I could also try to change what is in the value of my key 1 by calling out my key name, which is 1, and then putting in the value I want it to be changed to. So over here, I want Python to be changed to R. So I'm calling out the key value, which is 1. I'm calling out the key name rather, which is 1, and then I'm saying change it to R, and there it has been changed. I could also access elements in my dictionary using their key name. So over here, I want to know what is the value of key 2. So I called out key 2 and I have data science. You could also create an empty dictionary just as what we did for the list by calling out the empty dict, and you could add items with their key names. Here I just added an item. You could also add others, etc. So you could also create a dictionary with a list it as a key value. Okay, so I have a key state and I'm adding a list as my value for that key. Okay, so if I run this and I try to access, let's say I want to know what is in state, I'm going to get the entire list in state. But what if I wanted to get a particular value inside? So it's like a value inside a value, a particular value, and then I'm saying I want to know what is at index location 0 for that particular value, and I'll get Lagos. So let's take a look at functions and modules in Python. So introduction to functions, we have inbuilt functions as well as user-defined functions. So here are some of the inbuilt functions in Python. There are a whole lot of them. I encourage you to do some research on how they are being used and how to work with them. So I'll take you through how to define functions in Python. So functions in Python, if you've ever heard of the concept, dry concept, it means don't repeat yourself. That's what functions are for. It helps us not to keep repeating ourselves. So we could write a function for a particular purpose, and all we need to do is keep calling out the function and to run the purpose for which we've created it for. So how do we define functions in Python? We can use the def keyword. So we use the def keyword along with the function name and then a semicolon and a parenthesis. So we have the def keyword, the function name, parenthesis, and then a semicolon. Remember to always put in the semicolon. The semicolon indicates that you are creating a block of code, a function. And then to use that function, we have to call the function name, which we should define it as. So over here, remember how I kept creating variables? Anytime I want to call out the variables, I have to keep printing, which is really, I'm repeating myself because each time the variable name changes, I have to keep printing the name. So what if I wanted an automated process whereby I just have a user puts in into a name, and then for each time the user inputs a name, a message should print saying hello, and then username, and then nice to have you, without me having to always call out this entire statement. So let's see how that works. So over here, so remember, after declaring the function, I declared it with the def keyword, the function name, which is hello, and then the parenthesis, and then a semicolon. Remember to always put in the semicolon or you'll get an error, because the semicolon creates this indentation, which Python recognizes as a block of code. So if I call out the function, I'm going to be asked for a name, and I say dear, and it's going to say, hello dear, nice to have you here. So if I call it out again and change, I don't have to keep doing print. All I need to do is just call out the function and to automatically assume what I put there. So functions also take arguments. Over here, we did not put in arguments, okay? So it is, function also takes arguments. So if I define my arguments like this, I've made them required arguments such that if I try to call out the function without this argument, I'm going to get an error. So let's see how that works. If I try to call this with just, remember that I created two arguments here, L and B. So ideally there should be two values here, but I'm saying one, I'm going to get an error. See, missing one positional argument. But if I had come over here to put two values, I'll get my area calculated because it's a required argument. So one way of trying to make that optional such that it doesn't give an error is by using this asterisk before it, making it args. So I'm saying I want it to be an optional argument. So even if the user forgets to put the second value, don't give me an error, just print out a result for me. So if I run this again, I'm going to get, rather than getting an error as what we saw previously. So using the return statement. So in Python, when we create a function, we use the return statement. So what the return statement does is it executes that block of code and then exits it, unlike the print. So we're going to see the difference in a while. So if I run this, notice that I got an output, okay? I got an output for 5. Whereas for the print, take a look at what happens. I'm only getting a value being printed out. The function was not exited. I'm only getting a value being printed out. So that's like a difference between the return and the print. So we use the return most often. So using doc strings are multiple lines of comments, but they're mostly used in functions because you're trying to tell someone what your function does. Okay, so you use it. It's best practice to always include doc strings in your functions to tell a user that is trying to read your code what that particular function you created is doing. So over here, I'm just saying, hey, this is a function for calculating the BMI of a person in giving height in meters and weight in kg. Okay, so always try to use doc strings in when creating functions. So introduction to Python module. So what are modules? Modules are just it's like I have a whole lot of these functions over here, and I wanted them to be saved because they are only local to this ID, they're only local to this notebook. What if I wanted to be able to use them somewhere else without having to open my notebook all the time? So I could create it as a module. So all I need to do is just save it as .py, and then I'll be able to reuse it in any other notebook as much as I want to. And so that's what modules are. Modules are Python scripts containing classes, a whole lot of classes and functions that you can use and call out. So we're going to see some examples. So they allow reusability. Yes, you can always use them over and over again. So we have, these are some of the modules we have in Python: date, time, calendar, tokenize, and time. So importing a module. So how you import a module in Python? you call out the module name, import module, you call, or you do from module name import star, meaning from that module import everything, import all the functions, or you call out the module name and then with an alias, an alternative name. We're going to see how that works. So over here, I'm importing a module, a math module, and I'm calling out a function from it, factorial, and if I run it, I'm going to get string. So I can also call it another way by saying from math import star. That's import all the functions in math. So one of the functions in math is pi. So if I run this, I'm going to get. So I could also say from math import factorial as FCT. That's using an alias name. So it's just similar to what I did over here. So you notice that rather than calling factorial, I'm using FCT. So it's still going to work. So you see the usability of this when you try to import modules from libraries like matplotlib, and you're saying for matplotlib.pyplot, import matplotlib.pyplot as PLT. So using an alias, or import numpy as PD, using an alias rather than having to type the long library name. So you could check out all the functions in a module by using the help and then the module name over here, and you get to see all and how they work, to what they are used for, a description of them. Or you could use the DRI, the directory, and then the module name. So before we go, I'd just like to tell you the difference between the module library and the package. So while the module is a collection of functions and classes, the package is a collection of module, and then the library is a collection of package. So I'll explain that using Unilag. So in Unilag, we have Unilag. Unilag is a library. Inside Unilag, we have many faculties, the packages that do different things. And then inside the faculties, we have departments, the modules, okay, that have other functions they do. So that's another example of that. I have a bookshelf of a single book. The single book is a module. And then I have similar books there with particular, let's say I have this book for math, this shelf for math, this shelf for physics. That is like my package. And then the entire room where I have those and lots of shelves for different purposes is my library. I hope that explains it. Thank you for joining us today.